In this video, I am going to explain the elastic collision in one dimension. In elastic collision, we have two different cases. In this video, I am going to explain the first case. So for getting the idea for the first case, you have to see the figure. So what is given in the figure? If you see here, before collision, we have two masses, and these two masses m1 and m2 are coming with some initial speed. Once the collision takes place, what will happen? These two masses are moving in opposite direction to each other, and both will have a different final speed. So here I am going to explain the derivation for finding the final speed of the first mass m1, and also I am going to show the final speed of the second mass. So for this, I am going to make two videos. Actually, this derivation is a little bit lengthy, so I plan to make two videos. In the first video, I am going to show the derivation for getting this equation, and in the second video, I am going to show the derivation for finding the second mass final speed. Correct? Okay. If you want to get this answer, if you want to get this derivation, the final answer, you have to take a two main equation, which is nothing but the law of conservation of linear momentum. And also we have to consider the kinetic energy equation for this case. So once you frame the equation for a law of conservation of linear momentum and the law of conservation of the kinetic energy, we have to mix these two equations, and finally we will get the answer for the final speed of the first mass, and then we will get the answer for the final speed of the second mass, right? Okay, so let's start. So you have to frame the equation from the diagram itself. So you have to see the first mass. What is given in the first mass? You have m1 and v1I. So what is the formula for the linear momentum? For the formula for the linear momentum, we already studied in the theory. The linear momentum formula is P, which is equal to m multiplied by v. So here I am going to explain the concept in only one dimensional point of view. Correct? Okay. So now I am going to apply this formula for this diagram. Can we frame the equation? Okay. So for the first mass, what is the linear momentum? Law of conservation of linear momentum I am going to frame here. Okay, so you have to apply this formula for each masses, right? So first one, law of conservation of linear momentum, right? Okay, so how we can frame the equation? It's very easy, because we know the formula for the linear momentum. The linear momentum formula is mass multiplied by its speed or velocity, right? Okay, so can you please apply this rule for the first mass? If you apply this rule for the first mass, you have to write m1 v1I, right? Plus, because we have to write the before collision case, as well as we have to write the rule for after the collision, right? So now I'm writing the answer for before collision. So what's the linear momentum for the second mass? m2 v2I, right? Okay, which is equal to after collision. So what is in the after collision? m1 multiplied by v1 final plus m2 v2 final, right? So this is the equation for law of conservation of linear momentum for the case which is mentioned here. Understand? Okay. Likewise, I'm going to write the rule for law of conservation of kinetic energy. So because everybody we know the formula for the kinetic energy, I'm going to apply this kinetic energy formula for each masses. So law of conservation of kinetic energy. Okay, let's apply the rule for the first one. The first mass is m1, and which have the speed v1I. So we know the formula for the kinetic energy. So what's the formula for the kinetic energy? The kinetic energy formula is given by the rule half mv squared. So I'm going to apply this rule for each masses. So if you apply this rule for the first mass, we have to write half m1 v1 I square, right? And for the second mass, half m2 v2 I square, which is equal to half m1 v1 final square plus half m2 v2 final square, right? Okay. So now what I'm going to do, I'm going to rearrange this equation. Let's we take the first equation, the law of conservation of linear momentum. I'm going to rearrange this equation. So what I'm going to do, I'm going to move the mass 1 in one side, and I'm going to move the mass 2 in another side. Okay, so I'm going to take this equation, I'm going to rearrange. So what I'm going to do, I'm going to take these two in one side. I'm going to take these two equations, which is m2 v2i and m2 v2f one side, right? So what will happen? m1 v1i, when you move this m1 v1 final to the left side, it becomes negative, right? So m1 v1 final, which is equal to m2 v2 final, and when you move this m2 v2i to the right hand side, it becomes negative, right? So m2 v2 initial. Clear? That's it. Now here I'm going to take the common term. What is the common term here? m1 is the common term. So if you take this as outside, what is inside? v1 initial minus v1 final, right? Likewise, here also I'm going to take m2 as a common term. So if you take m2 outside, what will happen? v2 final minus v2 initial. So I'm going to take, this is my first equation. Likewise, I'm going to rearrange the law of conservation of kinetic energy. If you see the law of conservation of kinetic energy, we have half 1 over 2 in both sides. So we can cancel each other, both left hand side and the right hand side. Am I right? So now what I'm going to do, I'm going to take the law of conservation of kinetic energy, and again I'm going to rearrange. So how you can rearrange? So m1 v1 initial square plus m2 v2 initial square, which is equal to m1 v1 final square plus m2 v2 final squares. So now here also what I'm going to do, I'm going to separate mass 1 one side, I'm going to separate mass 2 another side. So what will happen? So I'm going to move this term to the left hand side, and I'm going to move this term to the right hand side. So by that we can easily separate mass 1 as well as mass 2. So I'm going to separate first m1. So m1 v1 I square. When you move this m1 v1 final square to the left hand side, it will have the negative value. By that m1 v1 final square, and here m2 v2 final square, and when you move this to the right hand side, what will happen? It will take the negative value, right? So m2 v2 initial square. Clear? Now we can take m1 as a common term. So what will happen? m1 v1 initial square minus, sorry, m1 we already take it outside, right? So v1 final square. Likewise here, m2 if you take as a common, the rest of the term are v2 final square minus v2 initial square, right? Okay. Now I'm going to take this equation as the second equation, right? Okay. Now I'm going to divide the second equation by first equation. So what we are going to do, we are going to divide the second equation by first equation. So the second equation is here, the first equation is here, right? So first of all, I'm going to take the second equation, m1 v1 initial square minus v1 final square, which is equal to m2 v2 final square minus v2 initial square, right? and we have to divide this equation by the first equation. What is our first equation? So this is our first equation, which actually here, this one. Okay, so I'm going to divide the left hand side. So for M1, V1 initial minus V1 final, the right hand side, M2, V2 final minus V2 initial, right? Clear? Now what I'm going to do, I'm going to explain. So this is our second equation. The top one is the second equation and the bottom one is the first equation. But if you see the top equation, we have V1 square minus V1 final square. Am I right? That means it is in the form of A square minus B square. We already studied this formula in our school life. Am I right? So what is the formula for A square minus B square? A plus B into A minus B. So we have to apply this rule here. So by that, if you apply, what will happen? M1, this becomes V1 initial plus V1 final and V1 initial minus V1 final. So I just simply expand this equation with A square minus B square rule, right? So what is the rule for A square minus B square rule? A plus B into A minus B. I am just simply apply this rule here. Likewise, in the right hand side also, this becomes M2 V2 final plus V2 initial and V2 final minus V2 initial. So in the denominator part, I'm going to write the term as it is, which is M1 V1 initial minus V1 final, and in the right hand side also we have M2 V2 final minus V2 initial. Now you can see we can cancel some terms, am I right? So which term we can cancel? You can see in the denominator we have V1 initial minus V1 final. In the numerator also we have the same term. So I can easily cancel. Likewise, I can cancel M1, M1, right? And also in the right hand side, we can easily cancel M2, M2, and also we can cancel V2 final minus V2 initial because we have the same term both in the top and the bottom. So what is the rest of the equation? The rest of the equation is V1 initial plus V1 final, which is equal to V2 final plus V2 initial. So this is the equation, right? Now what I am going to do, I am going to reform this equation. Which equation? I'm going to reform this equation in terms of V2 final. So I'm going to take this equation, this value V2 final one side, and I'm going to move the rest of the term to the left hand side. So what will happen? V2 final, which is equal to this term as it is, that is V1 initial plus V1 final. When you move this V2 to the left hand side, it will take the minus value, right? Okay, V2 initial. Understand? So let's we take this equation is our third equation. Understand? Now what I'm going to do, I'm going to make a simple substitution. I'm going to substitute this equation third in equation 1. So what is our equation 1? Actually, the equation 1 is here, right? So I'm going to take that equation. I'm going to substitute that value here. So better, I will write this equation 1 again here. So that will be easy for our calculation, right? So what is our first equation? Let's we just write the first equation one more time, which is M1 V1 initial minus V1 final, which is equal to M2 V2 final minus V2 initial. So this is our first equation, right? So now what I'm going to do, I'm going to substitute equation, that means substitute equation 3 in equation 1. So I'm going to take this, I'm going to substitute here. So you have to see in the left hand side of the equation third, we have V2F, am I right? So I'm going to simply take this value, I'm going to substitute that value here. That's it. It's a small mathematical arrangement, am I right? So simply I'm going to take this V2 final equation and I'm going to substitute in this equation 1. So by that, your equation will be exactly in a different form, right? So let's we substitute the equation third in equation 1. What will happen? By that, the equation 1 will become M1 V1 initial minus V1 final, which is equal to M2, and in this place I'm going to substitute this value here. So the value of V2F is V1 initial plus V1 final minus V2 initial, and one more V2 initial is here, so we have to write this V2 initial here, right? Okay. Now here minus V2 initial minus V2 initial, which is exactly equal to minus 2 times of V2 initial, right? So by that the above equation becomes M1 V1 initial minus V1 final, which is equal to M2 V1 initial plus V1 final minus 2 times of V2 initial. Clear? Okay. Now what I'm going to do, we have to do another mathematical rearrangement. So we got this equation. Now I'm going to multiply this term inside. If you multiply this M1 inside, what will happen? M1 V1 initial minus M1 V1 final, which is equal to M2 V1 initial plus M2 V1 final minus M2, that is 2 multiplied by M2 V2 initial, right? Okay. Now I'm going to take a common term outside. That means I'm going to separate V1 final one side. So how many V1 final we have? We have one V1 final term here as well as here. Am I right? So that means I'm going to take this term to the right hand side and I'm going to move the rest of the term to the left hand side. So what will happen? Your equation will become M2. I'm going to keep this term as it is. M2 V1 final. When you move this to the right hand side, what will happen? It will take the positive value, right? So this becomes M1 V1 final, and the remaining term, I have to keep this term as it is here, that is M1 V1 initial. When you take these two terms to the left hand side, what will happen? It will take the first one will take negative and the second one will take the positive, right? So this becomes minus M2 V2 initial, and this term becomes plus 2 times of M2 V2 initial. Clear? Now I'm going to take V1 as a common term, V1 final, because we are going to find what's the value of V1 final. So if you take V1 final as a common term, you have M2 plus M1, right? And here I'm going to take V1 initial as a common. So how many V1 initial we have? We have, V1 initial. How many terms we have? V1 initial here. This is V1 initial. I just made a mistake here. So this is V1 initial. See here, we have this V1 initial, right? So I'm going to take V1 initial as a common term. So V1 initial, if you take as a common, what will happen? M1 minus M2, and this one 2 times of M2 multiplied by V2I. Clear? Okay. Now I'm going to rearrange this equation one more time in the form of V1 final. So therefore V1 final, which is equal to V1 initial M1 minus M2 plus, I can just remodify in the different way, because I'm going to write V2I first and then 2 times of M2 like this. By that your equation will not change here, right? And divided by, because when you move this term to the right hand side denominator, what will happen? This term is common for this both term, right? Which is M2 plus M1. Now can you please, we are going to divide this into two parts. By that what will happen? V1 final, which is equal to V1 initial M1 minus M2 divided by M2 plus M1 plus V2 initial 2 times of M2 divided by M2 plus M1. So this is the final equation for finding the final speed of the first mass, right? So this is the answer. So now what I'm going to do, let's we compare our answer with the answer what I showed in the starting of the video, right? So let's we take that equation and we have to check whether our answer is right or not. So I'm going to take this term, I'm going to paste this term near to our equation. By that we can verify whether our answer is right or wrong. Clear? We'll expand. Okay. So we have V1 final, here also we have V1 final. Here we have V1 initial, here also we have V1 initial, and in the numerator we have M1 minus M2, here also we have the same, and the denominator we have M2 plus M1, here also it's same, and here we have V2 initial, here also we have V2 initial, 2M2, here also 2M2, and the denominator we have M2 plus M1. That means our answer is completely verified. So that means the steps what we handled here was perfectly right. Clear? So here I explain only the final speed of the first mass. Am I right? So I'm going to make one more video. In that video, I'm going to explain what is the final speed of the second mass. Right? Thank you. Please watch the second video. Okay? For getting the clear idea about what is the final speed of the second mass. Thank you.